Now, good day, good day, good day. And if you're the first time you are coming to my channel, make sure you subscribe and you share. Yes. Now, this is Apostle Daniel Annan, yes, from Infantipim School. Now, I'm coming to continue with the special angles, and this time around, I'm going to talk about how we can derive all the special angles. Special angles like 30 degrees. Not only 30 degrees, I'm going to derive the 60 degrees too. Yes. So I'm going to derive the 30 degrees and then the 60 degrees. Then we see what we can do. Now, the question that you were given as assignment is what? We are to use an equilateral triangle to derive the 30 degrees. Yes. Now let's look at this. Let me consider equilateral triangle. Now let's consider an equilateral triangle with side 2 units. Now let me consider a quadratic triangle with side 2 units. Now if I have a quadratic triangle with side 2 units, it means that this will be my quadratic triangle. Now this side will be 2, here will be 2, and then from here to here is 2. Now I want to derive this one to get a right angle triangle. Now before I can get the right angle triangle, I need to indicate the height of the equilateral triangle, which is equidistance from the top here up to here. Now, the moment I draw a straight line from here to here, what is going to happen? Since this one is a quadratic triangle, the straight line will divide this line into 2. So therefore, here will be 1, here will be what? 1. I hope you are following very well. Yes. Now, what happened is that this one becomes a rectangle triangle, this one becomes a rectangle triangle. So when I consider one side, if I consider one side, here becomes 90 degrees. This side becomes 90 degrees. This side is 2 units. And then this side will be 1 unit. Now this side is not known. We don't know this particular side. So therefore we can solve for this side, right? Okay. Now let's solve for this side. Now assuming here is m. Then from our Pythagoras theorem, you're going to have what? Hypotenuse squared is equal to opposite square plus what? Adjacent squared. Okay. Now let me label here as A, B, C, D. Now what's the hypotenuse? The hypotenuse will be AC, right? And then AC is 2. The hypotenuse is AC. The opposite, I have not considered any angle, so I can choose any part as my AC, as my opposite. So let me consider opposite to be BC plus A. What is adjacent? Let me consider adjacent to be AB. Now what is AC? AC is the hypotenuse, which is 2. So 2 squared. BC, the BC is m. So we have m squared. And then AB is 1. So we have 1 squared. Now this one will be 4 equal to m squared plus 1. We're going to have 4 minus 1 is equal to m squared. We're going to have m squared is equal to 3. Then what will be m? The square root of 3. Now m is the square root of 3. We can bring plus or minus back because this one is length. I can't introduce minus here. So it means this side is root 3. This side is what? Root 3. Don't forget our equilateral triangle here. Now, at this particular point, let me deal with the angles. Now, don't forget that equilateral triangle has all the sides equal and then all the angles equal. And then 180 divided by 2 gives us 60. So this angle will be 60, here will be 60, and this side will also be 60. Now, so it means that this angle is 60, this angle is 60, here will be 60, right? Because here and here the same. Now, and then this angle, what is going to happen? This straight line divides this line, this angle into two. So here will be 30, and then this side will also be 30 degrees. Now, when it happens, let me, this particular angle is 30. It's just as simple as that. So with this, I can now solve for 30 degrees. Now, let me solve for 30 degrees. So let's start sine 30. Now I want to use this particular angle. Don't forget that sine is, I'm using the SOHCAHTOA one. Now don't forget sine is opposite over hypotenuse. Now, so if the angle here is 30, then the AB will be the opposite. So the opposite will be AB. The hypotenuse is what? AC. So you're going to get 1 over 2. So anytime you get sine 30, it is 1 out of 2. Now let's solve for cos 30. Now what is cos 30? The cos is adjacent over hypotenuse. Now the adjacent is 30. The adjacent is what? BC. The hypotenuse is AC. Now what is BC? BC is root 3. And then AC is what? Is 2. So which means that anytime you have cos 30, the same as root 3 out of 2. Now let's move on to tan 30. Now what is tan? Tan is opposite, that is AB, over adjacent. The adjacent will be here, that is BC. Now what is AB? AB is 1. What is BC? BC is root 3. Now this one we can easily rationalize. If I want to rationalize, I'm going to get multiplied by root 3, multiplied by root 3. We're going to get root 3 out of 3. So tan 30 is root 3 out of 3. Now, this is what the question is looking for. Now I'm going to go ahead to prove the sine 60, cos 60, and then tan 60. So let me go ahead. Sine 60. Now, if I want to consider sine 60, don't forget the angle here is 60. So our concentration will be here. Now, when it happens like that, this side will rather be the opposite, and then here will be the what? The adjacent. The hypotenuse remains the same. You get it? Yes. Now, so what is sine? Don't forget that we have complementary angle. Sine 30 is the same as what? Cos 30. This sine 60 and then cos 30, we have to get the same answer. Yes. Go to our previous video to go and check complementary angles. Now let's look at this sine 60. So sine is opposite. The opposite here is BC. Over hypotenuse, the hypotenuse will be AC. Now what is BC? BC is root 3, and then AC is 2. Can you see that the sine 30 and then cos 30, they are the same? Yes, so sometimes you don't have to memorize, you're supposed to be able to understand. Now, cos 60. Cos is adjacent over hypotenuse, adjacent over hypotenuse. Now, the adjacent is AB, the hypotenuse is AC. Now, what is AB? AB is 1, AC is 2. Now, what are we getting for cos 60? Now, cos 60 is 1 out of 2, which is the same as cos 30 because they are complementary angles. So, we're supposed to get the same thing here. Yeah. Now, let's look at the last one, tan 30. Tan 60. Now what is tan 60? Tan is TOA, that is opposite. Opposite is BC over adjacent. Adjacent is AB. Now what is BC? BC is root 3. And what is AB? AB is 1. So it means that tan 60 is equal to root 3. This is so simple. I hope this one is very simple for you, right? Yes, this is very, very simple. Now you can see the complementary angle, how we can prove the sine 30 and then sine 60. These ones are equilateral triangle where all the sides are equal. And if all the sides are equal, if I consider equilateral triangle with a side of what 2 units, it means all of my 2 units. When I divide this one into 2 to get a right angle triangle, then here's supposed to be 1, here's supposed to be 1. You get it? You solve for the remaining side, then you get the answer. Now this one is so simple. The special angle is supposed to be at your fingertips. Don't forget, when they ask you a question about some questions, you're supposed to know the special angles. Yes. Now, in our next video, I'm going to talk about how we can prove another special angle, 0 degrees and then 90 degrees. Then from there, I will proceed to solve some questions based on the special angles. Now, I'll see you in the next video. Bye.